Let us discuss on this question now. The question says, the path followed by projectile is parabolic provided it is not projected vertically upward. So when a particle is thrown upward in Earth's gravitational field, so which force is acting on it? It is the gravitational force. And that gravitational force is always vertically downward. It will not be having any component in the horizontal direction. So what does this mean? From the Newton's law, it will go up in a straight line, and through the same straight line it will come back to Earth. But when the particle is projected at an oblique angle from the Earth surface, so it will have both the components. One component will be in the y direction, that is vertically up direction, and one component of velocity will be in the horizontal direction. So let us make this diagram. And if we say this as x-axis and this as y-axis, okay. X and y-axis, and this one we should say it is v naught, not representing at t is equal to 0, means initial velocity with which it was projected, and this is the angle theta from the horizontal at this oblique angle from the earth surface. This is your earth surface. It has been projected like this. So this is velocity. So it will have two components. One will be in the vertical direction. It will have a component in the vertical direction. Horizontal component. The vertical component. And you know that this will be horizontal component will be V naught cos theta, and vertical component will be V naught sin theta. This is your origin. We take the point of projection as an origin. So it is saying that if the particle is not projected vertically upward but at an angle theta from the Earth's surface, so it will go on a path of parabola. So you know the equation for, since it is talking about the path, the parabola path or the path. So path means you will have to find a relation between y and x of the particle at any instant of time t. So how do you write the equation for y? Initial velocity in the y direction, that is v naught sin theta, into t minus half g into t square. What will be the position of the particle in x direction at time t? In x direction there is no acceleration, so velocity will be constant. It will be v naught cos theta into t. T will be your x by V naught cos theta. If we place the value of t is equal to x by V naught cos theta in equation y is equal to this, we will get the equation as this will be your x tan theta minus gx square by 2 V naught square cos square theta. So your tan theta is constant, g is constant, 2 V naught square is constant, cos square theta is constant. So it is an equation of so it is a quadratic equation in x for the y as a function of x. So you can say that this equation is a y as a function of x. And what kind of function is this? This is a quadratic equation function. So we know that when the equation is quadratic between two variables, such as in this equation, so then the path followed will be a parabola. So when you trace this, the path for this, you will get a parabolic path. So the first answer for part 3 will be true. Second one is saying, if a projectile is projected from horizontal ground, angle of projection is 45 degree for maximum range. So maximum range, you know, so you have written the formula for range. So when this sine 2 theta will be maximum, your range will be maximum. So for which value of sine 2 theta? The value of sine 2 theta will be maximum. That is when 2 theta becomes 90 degree. So this will become your 1. So R max will be u square sine 90 degree by g. That is u square by g. But we have replaced 2 theta with 90 degree. So your 2 theta is equal to 90 degree. So theta will be 90 degree by 2. That is 45 degree. So we can say that for 45 angle of projection, when it is 45 degree, the range of projectile will be maximum. So this statement also is true.